Hi, I'm Anusha Agnor from PQI, and today you're watching a PQI Profiles, a show in which we get to know our members. So today I'm joined by Amy Carlson, who is from Chemistry Department at Duquesne University. She is currently a fourth-year Ph.D. student in Professor Evanseck group, working in the area of surface interactions. Amy, welcome to our program.
Thanks.
And firstly, congratulations on winning the Poster Award at Science in 2017.
Thank you.
So how do you feel about it?
Science one, I feel like it's different because I just got like the echoes. I won the big award last PQI, and I guess that like impacted my life more.
So which award was that?
Like the travel award.
Oh, the Travel Award. Okay.
So then at science, I won the like veteran award.
Oh, okay.
Um,
So is it just one time award, or did you like win other awards too?
I mean, I won the PQI one, and then, which was the travel award, and then the next year, or the next fall, I won the science award, which
Okay.
was, like, I got my choice of, like, some Amazon Echo
Oh,
products, so I
okay.
got the Echo Spot. But, I mean, winning the big award did a lot for me, so.
Amy, like tell us about yourself, where you grew up, and a bit more about your background.
So I grew up in northwest Pennsylvania in a small town called Oil City, really just the middle of nowhere. And then when I was in high school, I moved to the South Hills of Pittsburgh, and that's where I actually graduated from South Fayette High School. And then I went to get my undergrad at Seton Hill University in Greensburg, which is just east of Pittsburgh, and I got my degree in chemistry. I actually originally went to be a physician assistant. I always thought I wanted to do medicine. Until I got there and discovered I really loved chemistry. So I switched to doing chemistry when I was at Seton Hill. I got to do a little bit of undergraduate research there and then decided to pursue my Ph.D. at Duquesne.
So you told me that you do research on surface interactions, right? I'm curious to know like what you actually do in your research, and what's your prime motivation to take up surface interactions?
So I actually collaborate with an experimental chemist at Duquesne, Dr. Ellen Gewalt, and she works on surface modification of biomedically relevant metals for implant materials. So if you can change the surface interactions, you can change how these metals are going to be treated by the body to prevent rejection, I shouldn't say rejection, to prevent foreign body responses, to serve as drug delivery vehicles, things like that. But what I do as a computational chemist is I'm trying to get a closer look at those actual surface interactions that are happening. So they use molecules that are called self-assembled monolayers, which are long-chain alkyl organic acids. And actually a good example of self-assembled monolayers is Rain-X, which you spray on your windshield. It's very easy to apply, and you can kind of apply that same concept to these implant materials.
Okay.
So I'm looking at specifically the organic acid part of the molecules that comes into contact with the oxidized surface of these implant materials and trying to understand that better.
Okay, I mean I can totally associate with your research because I studied shape memory alloys, essentially like one of the biodegradable alloys which can be used as implants. So I'm also curious to know like what major applications do you focus on? I mean you're a computational chemist, so what are the major applications that you generally focus on?
So what I actually do day to day doesn't necessarily apply back, I guess, to that larger surface modification picture, but really trying to investigate different theoretical models and see how accurately they are describing these surface systems, because surface chemistry from a theoretical perspective kind of lies at the intersection of solid state physics and gas phase chemistry, and there are a lot of theoretical methods to describe both of those things that are both accurate and computationally feasible as far as time, but when you get to this interface between gas phase molecules and solid state surfaces, there are a lot of challenges regarding how to properly describe that on a feasible timescale. And so that's kind of what I've looked at in my research that I've presented for PQI is in the places where there is experimental data, how well can we represent that in reproduce that experimental data using different methods.
What's the most exciting and rewarding thing about your research?
What I really like about my research is that it is a collaborative project, and I get to regularly attend the group meetings of the experimental collaborator that I work with. And I think, every week seeing the research that they're doing in their lab kind of ties me back to why I'm doing what I'm doing and kind of what the end goal of my computational research is. So even though I do focus a lot on these different theoretical methods, I want to see the end goal of how this is going to impact people.
Okay.
Also, I really like being able to share theoretical methods with people that don't do it regularly. I think it's made me a stronger scientist to kind of simplify the problem and present it to other people. So I really like getting experimentalists to sit down and listen to me explain computational methods to them.
Okay.
And see, as it washes over their face, that they actually get it. And I really like that.
Well, I think that's really interesting. So I'm also curious to know your collaborators, because you do a lot of collaborative research as well. So who exactly are your collaborators?
I collaborate with Dr. Ellen Gewalt.
Okay. So is he from Duquesne?
Yeah, she's from Duquesne. Yeah,
Oh.
she's actually the chair of the department.
Oh,
Chemistry.
okay. So I'm sure, when you do research, you cannot expect results to be always optimistic. You tend to expect failures. So what are the most challenging aspects of your research?
Kind of like I talked about before, the whole problem regarding computational time and accuracy with my methods is definitely a struggle. I've been working with methods that are really computationally costly, and we do have the advantage that we have clusters of computers at Duquesne, even though it's a small school, that we can run all of our calculations on. But kind of just waiting around, and then if something failed, having to go back to the drawing board, that's always a challenge. And I guess for me personally, how theoretical my research has gotten, I try to keep it grounded back to the experimental relevance, but sometimes you just get so into a project that you can't really see how this is ever going to impact people, and I think that can be challenging. But working with a collaborator really helps in that regard. Also, I'm taking a class at Pitt right now that is actually completely experimental. It's biomaterials and biocompatibility, and the fact that I've been interacting with this group that does this sort of work for 4 years means that even though I do a lot of computational work, all the other classes I've taken in grad school are a lot of theoretical chemistry and math-based. Interacting with this other group has given me a lot broader picture of the field, and I'm able to do really well in this class. I'm actually really enjoying it.
I think that's really cool. So you mentioned you're a computational chemist, right? So what are your long-term goals? I mean, do you plan to get into academia, or are you trying to escalate into industry eventually?
I'm definitely interested more so in doing industry. I'm not entirely married to the idea of doing the exact chemical research that I do now for the rest of my life. I think what I like best about grad school is how it's more developed my data analysis skills, and also a lot of the computational skills that I've gained over my 4 years in grad school. And that's kind of where I'm more focused on using those and more of a data science type aspect in industry once I graduate.
Okay, I think that's where my interest is too. I mean, I do a lot of data analysis work. So how do you describe your experience at Duquesne? I mean, you're currently in the 4th year of your Ph.D. So how has been your experience so far at Duquesne?
I really enjoy it. We have a fairly small department, and I really like the small school feel. That's really why I picked Duquesne. I went to a really small undergrad, went to a really small high school, and I like that the professors there really have a balance of focusing a lot on teaching and a lot on research. And I think that's reflected well in, I'm a teaching assistant, and I've been a teaching assistant the entire time I'm at Duquesne, but it's something I actually really enjoy doing. So I like the smaller school feel, smaller labs, a lot of one-on-one time with the professor, and I think that smaller school environment kind of leads to these collaborations that we can take part in, like my project with Dr. Google.
Okay, that's really interesting. So you also told me in one of our discussions that you took, you're taking one of the courses at Pitt, right, which is a cross registration.
Mm-hmm.
So how has that experience been so far, which is an experimental course that you're taking here?
Yeah, I definitely like cross-registering for classes at Pitt a lot. Duquesne has graduate level courses in chemistry, but they're often special topics that will be taught by a professor that is kind of their specialty. So they're only offered so often, and I've definitely had the opportunity to take some of those, and they've been wonderful classes. But especially something like biomaterials and biocompatibility, really one of the few people that does that sort of work at Duquesne is Dr. Gould. So there's just not as much interest for it there. But the professor that teaches it here at Pitt is like a leader in this field.
Okay.
And just to be able to come over here, really simple, just hop on the bus and learn from like this leader in the field every week. I really like it. It's a really good course, and it's definitely been a good experience.
Right.
And I know other students at Duquesne as well that take classes at Pitt, and they really like it.
I think that's the best part of cross-registration. So you did your high school in Pittsburgh, and now you're again here for your grad school. So do you have anything to talk about Pittsburgh as a city in general?
I don't consider myself a city person necessarily,
Mm-hmm.
but I think Pittsburgh is a nice balance for that. At Duquesne, pretty much everybody commutes in. There's not a lot of housing that's right around Duquesne. So I live in Regent Square, and I live 2 blocks from Frick Park, and I think Frick Park is one of my favorite things about Pittsburgh. I go for runs there all the time, and I like that Pittsburgh it never feels like a huge city, because every neighborhood is kind of like its own little town. So I really like the city.
Okay. You're like being a grad student, you don't get, a lot of spare time. But what's your favorite pastime? Like hobbies? What do you do?
I always take time to cook. My
Wow.
friends even make fun of me for this, but especially if I feel like I have the time, I will cook dinner every single day. I really don't like getting takeout. I've recently gotten into making pasta from scratch. Like, I got a pasta maker for Christmas, so definitely cooking is one of my biggest things. I love cooking for my friends, and also running. I like to do that, especially with friends. I live with one of my best friends. She's a grad student here at Pitt in the
Okay.
Jordan Lab, and also my neighbor is another grad student in the Jordan Lab at Pitt, so we like to get together and go for runs a lot.
Wow, I think I totally associate with you because I love cooking a lot. I'm so happy to encounter someone
Maybe
who
we should
loves
just
cook.
be best friends.
Oh yeah, that's true. But I'm really glad to know someone who loves cooking. So Amy, I would like to know your experience with PQI, and would you like to give any advice to students who plan to apply for poster awards that you won before?
I can't honestly remember how I ended up coming to PQI the first year.
Mhm.
I think my boss got an email, he forwarded it to the whole group and said, here's this poster session, everybody in the lab has to do it. And I was like, okay, this is stressful. I think it was my second year. And then, I ended up going to the poster session. I came back on Wednesday evening for the regular PQI conference, and came back the next day and went to a couple talks, and then got to go to the banquet at Phipps, and I went with a couple of my friends that were also Duquesne students at the time, and I just thought it was like a really great experience. It was, it was so easy and so close, like right here in Pittsburgh, but I got to see all this amazing research. And one thing Duquesne doesn't have a whole lot of is, kind of quantum-based research. There's only a couple of professors in the department that do it. So it was really nice to have everybody, in one place, only talking about that all the time, all this theoretical, physics and chemistry flying at me. And I did the poster session the first year, and then the second year I did it, which was last year, is when I won the poster award. And I would definitely encourage people to do it, because I think the more you present your research, the more you get comfortable with talking about it.
That's true.
I got to take the same project that I presented last year at PQI. I just went to New Orleans for the ACS National Conference 3-4 weeks ago to present that same poster and a different one. And especially that one, I presented it, relatively the same project a couple times, a couple different places, and I just felt really confident about it, and I definitely, I think that showed when I presented it to people at the National
So
Conference.
Amy, it was real fun interviewing you today, and I'm very glad that you're here today. And thank you so much for being on our program. So this has been our PQI Profiles, and thank you so much for watching.